Okay, so let's talk about square roots. We had talked in class about square roots, and we looked at what we knew so far about exponents. And if you're not sure about exponents, you need to go back and watch the video about exponents. Because we took our knowledge about exponents, brought it out into a factored form, drew a model, found the answer. Well, that answer is a perfect square. So when you have a perfect square, we were trying to find a square root. To find a square root, you are looking for a number times a number, but those two numbers have to be the same and equal what's in your square root. So for example, the square root of 4, how we find it, what times what equals 4? Well, it's 2 times 2, so the square root of 4 is 2. You just say the base once to answer the square root. We don't say the square root of 4 is 2 times 2 because that's the process of getting there. So the square root of 4 is 2. For 9, the square root of 9, well, what times what? That's the same number gives us 9. Well, 3 times 3 is 9, so that means the square root of 9 is 3. Look at 16. What times what gives you 16? That's the same number. Well, it's 4 times 4, so the square root of 16 is 4. We also did 25. Well, what times what? That is the same number gives us 25. Well, 5 times 5 gives us 25. So the square root of 25 is 5. We did 36. We're looking for two numbers that are the same multiplied together that give us 36. So that's 6 times 6 is 36. That means that the square root of 36 is 6. And 49. What times what? That's the same multiplied together gives us 49. Well, 7 times 7 equals 49. So the square root of 49 is 7. So you could go higher than that. Square root of 64 would be 8. The square root of 144 would be 12. Why? Because 12 times 12 is 144. Then we looked at square roots that are not just perfect. These are perfect because we found those two numbers that were the same. We could easily find the square root. These are not so perfect because you cannot find two numbers that are the same to equal. So let me give you an example. Square root of 19. Well, you can think and think, and there is no two numbers that are the same that would equal 19. So instead, because we're 6th graders, all we have to be able to do is go back and look at our perfect squares. What perfect square would 19 fall between? We'll look at it like just a normal whole number. 19 would fall before 4 and 9? No. 9 and 16? No. 16 and 25? Yes. 19 would fit somewhere in between there. So we are going to say that 19 is in the middle of the square root of 16 and 25. Well, we're trying to answer what is the square root, so we're not going to answer in a square root. So we said the square root of 16 is 4. The square root of 25 is 5. So if I asked you the square root of 19, you would tell me the square root of 19 is somewhere between 4 and 5. You wouldn't want to tell me the square root is somewhere between the square root of 16 and the square root of 25 because you don't want to answer in a square root form. So your correct answer would be between 4 and 5. Okay, let's do another one. The next one, 27, square root of 27. Okay, so you think, well, 1 times 27 is 27, those aren't the same. 3 times 9 is 27, but those two numbers are not the same. So we don't have a perfect square. So let's see where 27 would fall. Would it fall between 4 and 9? No. 9 and 16? No. 16, 25? No. 25, 36? Yes. would fall somewhere between 25 and 36. So it would fall between the square root of 25 and 36. We know that the square root of 25 is 5. The square root of 36 is 6. So that means the square root of 27 would fall somewhere between 5 and 6. Now today in class we had the number 20 that kind of stumped some of you. So I'm going to change this 22 to a 20. Square root of 20. Okay, so I told you get out your notes and look. Well, you should have found on your notes there is no 20. There's no two numbers. 1 times 20, yes. 5 times 4, yes. But those are not the same numbers, so we don't have a perfect square root. So instead, let's find what would 20 fall between. Okay, 20 would fall between 4 and 9, no. 9 and 16, no. 16 and 25, yes. So just like the 19 up here, square root of 20 would fall somewhere between the square root of 16 and the square root of 25, but we don't want to answer in square root form, so we need to take the square root of 16 is 4, the square root of 25 is 5, so our answer would be the square root of 20 is somewhere between 4 and 5. Let's have you try one. Let's try the square root of 21. Okay, so let's start off. 21, pause the video, come back and check with me. Okay, so you should have tried this on your own. So you have the square root of 21. You know it's not perfect. Your factors are 1 and 21, 7 and 3. None of those are the same numbers, so you're not finding that perfect square root. But you can look at your perfect square roots and figure out, well, where would the square root of 21 fall? Between 4 and 9, no. 9 and 16, no. 16 and 25, yeah, that would work. So here's another one. We keep going to the 16 and 25. Square root of 16 is 4. Square root of 25 is 5. So your answer would be between 4 and 5. We're going to do one more and try to get away from this 4 and 5. Okay, let's try 40. 40 again. Put here, square root of 40. Go ahead and pause the video, try it on your own, and then come back and check. Okay, so 40, we could do 1 times 40, those aren't the same. 2 times 20, those aren't the same. 4 times 10, those aren't the same. So nothing that we combine is going to be the same two numbers to get to a total of 40. So instead, let's look. This one shouldn't be between 16 and 25. But is it 25, 36? No. 36, 49? Yes. It would fall somewhere between there. So the square root of 40 would fall between the square root of 36 and the square root of 49. Square root of 36 is 6. Square root of 49 is 7. So the square root of 40 would fall somewhere between 6 and 7.